Color. If we take the visible spectrum and we break it up into three main sections, and we call these frequencies primary blue, primary green, and primary red. Imagine we had a red spotlight, and then a separate green spotlight, and a third blue spotlight, and we overlap them like this. Then, where the green and the red overlap, creates a secondary color of yellow. Here, the red and blue overlap, we get magenta, and finally cyan or turquoise. And where all three spotlights overlap, you would get white. We can't achieve this with our Raybox equipment in terms of circles, but we are able to show the colors overlapping. Adding colored light, we turn the Raybox around and we put some filters in and use the mirrors so that we can add the different colors. If we add primary green and primary blue, we end up with cyan or turquoise. Adding blue and red, we get a pinkish magenta color, and green and red gives us yellow. And if we add all three primaries together, we get white light. If we spin this color wheel very fast, eventually it appears almost white. And this is because all of the colors are entering your eye simultaneously. Complementary colors. Yellow and blue are complementary colors. Yellow reflects both red and green. It's a secondary color. So yellow and blue reflect all the colors and hence appear white. Similarly, magenta and green are complementary colors, and cyan and red are complementary colors. Adding secondary yellow with primary blue, it appears white. Adding secondary cyan or turquoise with primary red, we also get white. And finally, adding primary green and secondary magenta, we also get white. We have yellow object, also the handle of the hacksaw, red objects, blue objects, green objects. And through a red filter, the yellow object, the red objects, and the paper all appear to be red. Yellow reflects both red and green, and so the red is able to pass through the filter. But the blue and the green both appear black. Blue and green are absorbed by a red filter, and hence no light comes through to your eye and appears black. Through a blue filter, the blue objects plus the paper appear to be blue, but the green objects, the red and the yellow, all appear to be black. And through a green filter, the yellow object and the green objects appear green, but the red and the blue objects appear black. Well, green filters absorb red and blue, so none of their reflected light comes through to your eye and therefore appears black. Overlapping filters. Here we have the primary filters, and when we overlap them, it appears black, and that's because no light is allowed to be passed through. If we add the secondary colors, we have a different thing. The cyan and magenta allows the blue to come through, and that's because is common to both of them. The yellow and magenta appears red, and overlapping yellow and cyan appears green. Overlapping all three absorbs all the colors, and therefore it appears black. Mixing paint. When we add these all together, we're actually subtracting colors, not adding colors. And blue and red makes a purplish color. Yellow and red gives us orange. Blue and yellow gives us green. These are not great primary paints, and so it's a little bit of a dull olive green. And when we add all the colors together, the more we add, the more colors are absorbed, and so the darker and darker it gets. Eventually, we end off with a very dark brown, nearly black. In the litho printing process, we print separately the yellow, magenta, cyan and black. And each picture is made up of tiny little dots, and we put it all together. It appears like that. This is the Science Center exhibit, where you overlap those different colors. Black and magenta looks like that, and only once you have all of them together, CYMK, cyan, yellow, magenta and black, do you get the full colors. If we look at this little picture through this handheld microscope, then what that part resolves into is a bunch of dots. It resolves into cyan, yellow, magenta and black. Looking at microorganisms, appropriate maybe in these COVID times, this is what we got looking through the microscope. Shadows. Well, shadows are black because no light is transmitted through your hand. Can you explain why these shadows have colors? Wow. Cool, hey? And that's it so far. Thank you for joining us.